Hello everybody! I want to start with a picture, namely with this person here. Who remembers her? Does this picture somehow ring a bell? I give you a tiny hint, namely, yeah, she was from the Knight Rider team. She was Bunny. Back then, when I was a child, I did not even recognize that Bunny had a PhD. Somehow that was not a topic for me back then. And I really liked Bunny. Somehow she inspired me to do stuff with computers, because she was really good with this stuff. And I think she was one of the reasons why I told my parents they should buy me a computer. I told them I might need it for school, which was not totally true, but also not totally wrong. However, when I'm thinking back to Bunny, one thing only works in Hollywood. Namely, Bunny was a one-man, a one-woman show. And this does not work in engineering nowadays. Because engineering, computer science, and especially software engineering is a team sport, isn't it? We need to coordinate several people in order to achieve a given goal. And sometimes we even need to coordinate several teams. Because software is getting huger and huger, and so one team might not be enough. And you can imagine coordinating several teams is even harder. But an X got us covered. With an X we can define several folders with several libraries. And I really like it to define one folder per business domain. Per business domain that reflects this or that aspect of our business, like booking, check-in and luggage here. All those domains are domains of handling flights. However, you can even go one step further. More and more people start implementing micro frontends, which is basically nothing else than creating one application per business domain. That means we end up with really one application and we can assign a team of its own to all of those applications. They can work independently, they can do their own decisions, and because those teams are tiny teams, they can really work in an agile way. They can work to provide business value on a regular basis. They don't need to coordinate with each other. They don't slow down each other. However, if we talk about micro frontends, we also need to talk about runtime integration, because this is what we need when we go with micro frontends. The thing is, and I'm really sorry for this, the user is not interested into micro frontends. The user is not interested into any technical details. All they want to have is an integrated solution. And so we need somehow load all those tiny micro frontends in something I call a shell at runtime. The shell does not know all those micro frontends upfront because they are deployed and developed and even compiled independently. The shell only knows them at runtime when it loads this or that micro frontend into its working area. This is what happens here with this example. I have a micro frontend on the left and I'm loading it into the working area on the right. Doing something like this, runtime integration, was really difficult in the past. In the past you needed a lot of tricks for this. However, since about a year we have Webpack Module Federation, which is really the missing link here. It makes this straightforward. And now we can say, well, let's just put each and every micro frontend into a repository of its own to maximize the freedom, the flexibility of those teams. So that all those teams can do their own decisions, so that all those teams can choose their own version of the frameworks to use and even the frameworks. One team might go with Angular, another team might go with React. They shall use what they want and what helps them to achieve their goals. This would be one approach. However, beware what you wish for, as they say. Because even though this is possible with micro frontends, it brings a lot of disadvantages to the table. For instance, if you do this, if you distribute your source code into several repositories, you need to share your shared libraries using NPM. And we all know sharing libraries for internal purpose via NPM is everything but fun. We need to version them, we need to update the versions, we need to deploy them, we need to install them over and over again. Also, we can end up with version mismatches, because this all is about runtime integration, and so it might happen that we are loading at runtime two micro frontends that don't fit together, that use different versions of Angular or React or something like this. And then I guarantee you all hell breaks loose. And so I want to discover here with this talk if it is possible or how it's possible to combine NX with module federation, because module federation is really great when it comes to runtime integration, and NX has all those other issues solved. With NX it is easy to share code, with NX it's also easy to prevent version mismatches because everything is co-located. I've prepared 3 things for you today. I want to start with a general discussion about monorepos versus multirepos in the context of micro frontends. Then I want to go on with module federation in general. And then I want to show you some considerations that are important when combining module federation with NX monorepos, or to say the least, with monorepos in general. But first of all, let me introduce myself. I am Manfred, I'm a trainer and consultant for Angular, and my focus is Angular for enterprise scale applications. I'm doing a lot of workshops in this area and consultancy, and so I'm helping a lot of companies around the world. Besides this, I'm quite connected to the Angular community, as you see here. If you're wondering where this accent comes from, where I'm from Austria, I also do a lot of stuff in Germany, and as mentioned, I'm always happy if I can work together with people around the world. Currently, I'm doing this remotely, which really works well. Okay, let's get started with the first topic. This is the discussion about mono versus multi-repos in the context of micro frontends. And I want to start with multiple repos. Here we see several micro frontends subdivided into multiple repos. And as mentioned before, this gives us the highest amount of flexibility. Each team can use its own framework, each team can use its own framework version, each team can do their very own decisions. They don't need to coordinate much. Plus, everything is isolated from each other. This is one of the goals. We want to have isolated micro frontends so that one micro frontend cannot interfere with another one. And this goal is achieved with quite strict borders, namely with the borders of our micro frontends and of our repositories. A repository border is quite a strict border. Grabbing over this border using something from another domain is nearly impossible. At least it cannot happen by incident. I know there is something like Git submodules, but you really need to do this on purpose. This is one of the advantages here, besides having the highest amount of flexibility. However, as mentioned before, this comes at a cost. For instance, sharing libraries is really a nightmare because you have to share libraries via NPM. What does that mean? Well, that means you have to implement a library, you have to assign a version number, you have to publish it. You have to integrate the library in your application, you have to find out that there is a bug in there, because there are always bugs in there, and then you have to file the bug. You check out the library, you fix the bug, you assign a new version number, you publish it, you reinstall it, and you find out there is another bug. And this goes back and forth all the times until you are done or crazy, depending upon what happens first. So as you see here, it's not easy to share code via NPM. Another issue here, I've also mentioned it shortly at the beginning, is you can end up with version mismatches. If everyone can do what they want, we might end up with version mismatches in the shell, because the shell does not know the micro frontends upfront. And so it might be the case that we find conflicting versions in the shell at runtime. Angular X, Angular Y, React X, React Y don't fit together. However, if we went with a monorepo, we had a one version policy, one version for everything, and so we don't end up with version conflicts. Plus, sharing code is drop dead easy, because we have this shared section here. We check in our source code, we merge it against the main branch, and Bob's your uncle. However, you might wonder, how can we avoid coupling between business domains, between micro frontends? Because this is one of the general goals, avoiding that one micro frontend is dependent upon another micro frontend. But also here, one more time, NX got us covered. Because in NX we have a thing called access restrictions. That means we can configure that one part of the monorepo can only communicate with selected other parts. Here, for instance, if you look at this error message, I have defined that something in the domain boarding can only communicate with other things in boarding and with things in the shared part of my monorepo. But boarding cannot communicate with booking, luggage or check-in, which gives us the separation we really want to have when going with micro frontends. If we didn't have this isolation, then teams would need to coordinate with each other, and it's one goal to avoid this. So let me recap. We have seen so far this is all about our dark-kick teams. We have also seen it's about an individual deployment. And we want to have a one version policy. Here we are limiting ourselves, we are limiting ourselves, because we don't want to have all the freedom of mixing and matching different versions. In theory it works, in practice it brings a lot of issues to the table. That means we are really restricting ourselves, or to put it in another way, as Peter Barker said it, with a lot of power, there comes a lot of responsibility. And responsibility means here we don't use all our powers. We don't mix and match versions. Okay, so much for the first part. Now let's move over to the second part, which is about module federation in general. In overall, module federation is answering this very question here, namely, how can we load separately compiled source code? At the end of the day, we want to do something like this. We want to import something from over there, something that was separately deployed, separately compiled, separately developed. Something like this was not really possible before, and that's why Webpack 5 gives us module federation. And module federation in turn defines two roles. The first role is the host. In our case, this is the micro frontend shell. The second role is the remote. In our case, it's the micro frontend itself. And now we can configure the shell via the Webpack configuration. We can say, hey, let's map a URL here. Let's map the URL mfe1. It shall point over to a separately compiled micro frontend that's also called mfe1 over there. By the way, mfe1 stands for micro frontend 1. It's quite creative, I know. Over there, we can expose files. We can say, well, I want to expose this or that file for the shell. And for this, we are just pointing to those files and we are defining nice aliases. Here, for instance, I expose this file and I define this nice alias. And then something beautiful happens. I guarantee you, you will love it. Then all you need is just a dynamic import. And dynamic import pointing over there by using the map names. And so you can load something from over there that was separately deployed, separately compiled. The best of this is your leading framework does not even recognize that you are loading something separately here, something you have not been aware of at compile time. Because from your leading framework's perspective, this is just a dynamic import, or to put it in another way, this is just lazy loading. And this is really great, because that means you use your framework as is, as it was intended to be used. You don't stretch it, you don't need to deal with some additional meta frameworks. No, you just use your framework as is and you are fine. One technical detail here, when compiling the remote, Webpack is generating a remote entry point. It's just a tiny file, free case in production, give or take, and this file needs to be loaded somehow into the shell. For instance, with a dynamic script or with a static script like here. But you can also create a dynamic script with some DOM magic, or you can also use a script loader. After loading this into the shell knows how to interact with the micro frontend in question. One of the best features, however, is the feature to share libraries. You can say, well, I have Angular, you have Angular, so let's just share it. Let's just load it once at runtime and share it. Of course, this only works if both of them use a compatible version of Angular. For instance, Angular 12 here and 12.2 on the other side. Then Module Federation will decide dynamically at runtime for the highest compatible version, 12, 12.2, the highest compatible is 12.2. So how can we use it? Well, at the end of the day, you just need a special Webpack configuration for this. However, when it comes to using Angular, Webpack is hidden from us. And so we need a plugin. I've written such a plugin, you can use it. Just ng-edit and then adjust the generated configuration. When calling ng-add, the configuration for you is generated. You need to adjust it for your needs. And then you can ng-serve it, you can start it and find out that nothing works or that everything works, which is even more awesome. The cool people in the NX team also integrated this idea meanwhile directly into NX. At the end of the day, underneath the covers, the same things happen, but they have really nice schematics for this, or generator as they call it now. So everything you need to do is generating an app, and you can say, well, this app is a host, MFE type host. And then you can generate your micro frontend and you can say, well, this app is a remote, MFE type remote. You can define your own board and you can link it to the shell, which is here the host. It's really as easy as that. And then one more time, NX serve it and nothing works or everything works. It depends. Okay, let me show you a tiny demonstration for this. In this demonstration, here I have a shell, and here I have a separately compiled micro frontend. It allows us to search for flights. And the best here is, when clicking here to flights, then this micro frontend is loaded on demand. It's really a separate micro frontend. I'm even using separate boards here. So if we zoom in here, the shell runs on board 5000, the micro frontend runs on board 3000. And now, having different boards, having different origins is not a prerequisite. But here I'm using it on purpose to prove that we are talking about two separately compiled and deployed applications. Now let's have a look to the network console. When loading the micro frontend, let's refresh this, let's press F12. I don't need this here. And then let's go to the network tab. When we click here, then at first sight, it looks a bit like lazy loading. But at second sight, we see it's far more than lazy loading. Because this stuff comes from another origin, from localhost 3000. And obviously we are sharing Angular because this only has 10 Ks. That means Angular must be shared, otherwise the bundle would be far bigger. So let's have a look into the implementation of this example. When we look into this implementation, first of all, I want to get started with the Webpack configuration of the shell. You remember, this configuration is generated for you. Both ways I've shown you generate this Webpack configuration. And you don't need to worry, this is not a fully blown Webpack configuration. This only contains the stuff we need for module federation. So it's quite slim. The rest is still generated by an X or the CLI, to say the least. Here we have the module federation plugin, which is an integrated part of Webpack 5. And here, for instance, we are pointing to another micro frontend. Here I'm saying, hey, I want to map the URL MFE1. It shall point over there to a micro frontend. Over there it's also called MFE1. And by the way, here you find the metadata. Yes, I know this URL is hard-coded in the Webpack configuration. And the Webpack configuration is only evaluated on build time. So this is what I'm calling static federation. Static federation. It's the easiest for getting started, but when you want to go into production, you need dynamic federation, which is an alternative. And it allows you to define this metadata at runtime. That means at runtime you can ask your backend, which micro frontends do you have for me, and then you configure your system with this metadata. This here is not about dynamic versus static federation, so I will stick with the easiest approach, which is about static federation. If you want to learn about dynamic federation, look up my blog, you'll find some articles there. Okay, besides this, I want to share some libraries. Here I can mention all the NPM packages I want to share. And there are even some strategies for dealing with version mismatches. As you see here, I want to share Angular Core, Common, and the router. Okay, this is the Webpack configuration of the shell. We have quite a similar Webpack configuration for the micro frontend. Let's have a look into it. Webpack MFE1. So one more time, a partial configuration. In the center we see the module federation plugin, integrated part of Webpack. And here we see also some metadata, like the name of this micro frontend, the name of the remote entry point. You remember, this is where the metadata comes from at runtime. And here I'm exposing an Angular module. To say the least, I can expose everything. Each and every TypeScript or ECMAScript module can be exposed here. This here is just a traditional Angular module, an Angular module with subroutes. Let's look into it. You see, really simple. It has some subroutes, child routes, to say the least. And this allows us to jump to this or that child route after loading this module into our shell. And besides this, the Webpack configuration has also the same section for sharing libraries. All the micro frontends need to opt into sharing in order to get a shared library. NPM packages listed here in this section. Yeah, that's it more or less. That means everything we need to have is this Webpack configuration for the hosts and the remotes. And then we can do traditional lazy loading. Let's do this. For this, I'm looking into my app routes. This is the routing table of the shell. And here you see, this is just a traditional, very simple lazy route. A route having a path and pointing with load children to a module that is imported on demand. However, this module, I need to take care, this module is a mapped module. This is just a mapped name. These names have been mapped by Webpack, as we have seen before. MFE1 in the first Webpack configuration, module in the second Webpack configuration. So from Angular's perspective, this is just lazy loading. Webpack knows what to do, how to do the heavy lifting of loading something from over there. And TypeScript is not amused because TypeScript does not know about this file. And that's why I created a declaration file telling TypeScript, hey TypeScript, it's fine. If you see this module, it's fine. You don't know it, but it will work at runtime. Trust me, I'm an expert. Yeah, and that's all. So I think that really shows how easy it is to do runtime integration, even within a monorepo with module federation. So now let's talk about something you should consider when doing module federation with NX monorepos or monorepos in general. First of all, you will very likely want to share libraries. For instance, in my case, I have a shell and a micro frontend, and both is separately deployed. However, I also have an internal authentication library, and I want to share it at runtime. That means it will be compiled into both of them, but at runtime, only one version of it is loaded. It's loaded only once. That's also important for sharing data. Of course, this is nice for sharing code and for decreasing the needed bandwidth, but it's also important for sharing data because this library knows who the current user is. And so I want to use it just once. If I loaded it twice, perhaps the first version would say, I don't know the user, and the second version would say, hey, the user is Manfred. So who's right? Just loading it once solves this issue. And normally this really works fine with Webpack because we've seen it before. With Webpack you can share NPM packages. However, this here is not an NPM package. This is an NX internal library. Or to put it in another way, it is just a folder with a path mapping, a folder with a bunch of source code. However, the good message is Webpack got us covered. They also have configuration options for sharing a folder with a bunch of source files. Let's have a look into this. So if we look into this, we will see that we have here our library. It's not an app. It's a library. It's our auth library. This auth library comes with a service. It's my auth service. And here I'm implementing a very simple authentication logic. So if you look at this, this is what I'm calling login for honest people. It's my preferred way for implementing authentication, login for honest people. I found out if everyone is honest, authentication is far more easy. And of course, I want the shell to set the username, and I also want that the micro frontend can read this username. And so we really need to share it. And for sharing it, we can move to the Webpack config. And here we can use a configuration setting. We can say, well, I want to share my, how is it called? My Timo outlib. And then I can assign here a whole bunch of configuration options pointing to this or that library. This is not that easy. You need to consider several configuration options. And by the way, you need to tweak the Angular compiler a bit. Because also the Angular compiler needs to use the shared version of the library when compiling everything down to ECMAScript. First of all to TypeScript, and then with the TypeScript compiler to ECMAScript. So it's not that easy, but here I got you covered. I have implemented this helper method here. This helper method or this helper class is allowing you to register your dsconfig based JSON, and so it knows about all your shared libraries because the shared libraries have a path mapping in there. And then you just need to define which shared libraries you want to share. Which of them you only want to load once at runtime. Just enter here the name, the map name, and you are fine. Bob's your uncle. You need to do the same within the other Webpack configuration. Please remember, you need to opt in for each and every micro frontend if you want to share something. So we do the same here, and so we are fine. Now it's only loaded once. We only have one instance of it. The shell can write the username into it, and the micro frontend can read the username. This is also the key for sharing data. Saying this, normally you don't want to share a lot of data. Share as little as possible, because sharing data is coupling everything together. Okay, let's do it here. Username Manfred. I don't need a password because I'm honest, right? Log in. You are logged in as Manfred. And if we click here, we see, no, that was the wrong one. If we click here, then we see that my shell really shared this information with my micro frontend. Here I'm logged in as Manfred too. So because it's that cool, let's do it one more time. Now Jeff is logging in. And here we have current user Jeff. How cool is that? Okay, so another thing you should consider when going with an NX monorepo and module federation is how to deal or how to avoid version conflicts. Because here the outlib is shared, and perhaps both of them, the shell and the micro frontend one, needs a different version of the outlib. And perhaps you are saying, oh, well, that cannot even be possible because we have a monorepo, we have a one version policy. Well, yes and no. So here is a scenario that shows that we can have a version mismatch even though. Consider this as the time that is going from the left to the right. And let's say we are deploying a first micro frontend at this point in time. This micro frontend uses the shared library. And then we are changing the shared library, for instance, the offlib. And then we are deploying another micro frontend. If we load both micro frontends into the shell now, we have a version conflict, because they have been compiled with different versions of the shared library. That means while at one point in time we cannot have a version conflict, over time, when deploying little by little, we can get such a version conflict. And this is something we want to prevent. And for this, there are several solutions. For instance, module federation allows you to assign versions even though if you go with a monorepo. But that's not the best solution because we wanted to have a single version policy. Another solution is this here. You can always deploy all the changed applications together, all the changed applications you find in your release branch. That means if something is merged to release, then all the affected applications are deployed together. And here one more time, module federation got you covered. This is really simple with, not with module federation, sorry, with NX got you covered. This is really simple with NX because NX has these affected commands. Affected apps tells you which apps have been affected by comparing different branches. By default, everything is compared with the main branch, but you can also apply this to the release branch. And so you can call this command in your build chain, in your CI/CD process. And so the CI/CD process can find out what changed, and those applications are then deployed together. I have a little tiny bonus for you. We are more or less at the end, but there is a little tiny bonus for you. Namely, you can combine module federation with the NX cache. And this gives you awesome build times. It is really accelerating everything dramatically. And perhaps you are saying, well, we know the NX cache, it's really great. But no, together with micro frontends, it's even greater. Because micro frontends are applications, aren't they? And applications are really difficult for building. It takes a lot of effort to build them. Building an application is far more difficult than building a library. The reason is we have more optimizations in there, optimizations like tree shaking, for instance. And the effort for this grows exponentially with the size of the application. Hence, slicing a huge application, a monolith, into micro frontends and caching the not changed micro frontends, or to say the least, taking the not changed micro frontends out of the cache, is speeding up everything dramatically. We really did or received good numbers when trying this out with our customers. Of course, you can also cache libraries, and if you do both, you get even a better build performance. So please keep this in mind. So we are reaching the end of this. If you like this talk, you will very likely like my ebook. You can download it here. Let me come to a conclusion. We've talked about runtime integration because module federation and micro frontends are all about runtime integration. We talk about applications that have been developed and deployed separately, and at runtime they are loaded into the shell. And we do this to get autarkic teams that can do their own decisions. Even though there is a huge software system to build, each sub-team can do its own decisions. This brings back agility to huge teams. We've also talked about limiting ourselves a bit, restricting ourselves a bit with a one version policy. Even though we could mix and match versions, it's not the best idea, especially it's not the best idea in the front end where everything needs to be loaded into the client. So restricting ourselves is a good thing to avoid issues. And we've talked about access restrictions, which really help in the world of NX to separate several micro frontends, several business domains, because this is what this is all about. We need to isolate them in order to get autarkic teams. And there is one last thing I really want you to remember, namely the Peter Parker principle. With great power comes great responsibility. Even though we have the power to mix and match versions, we don't do it in order to prevent issues. We don't use all our power. Quite nice, isn't it? So here you have my contact data. I've already uploaded the material for this, the examples and the slides to my blog. And follow me on Twitter to stay in contact. Thanks for having me. Have a nice day.